this.
Oh, no. Of my. Okay, 40 pack of 20 bottles, 20-ounce bottles of soda. So think about what you're buying here.
Soda.
Soda, there you go. You're buying 4 bottles, and each bottle has 20 ounces. 20, 20, 20. So in total, you actually bought 80 ounces of soda. So they're asking you for the price per ounce. So let's write that as a rate. Let's write it as a fraction, 579 over 80 ounces. And to find the cost per ounce, you literally find the unit rate, right? So 1 ounce, divide by 80, divide by 80. If I'm pretty sure you have to, what do you call, round this up, or round it. 5.79 divided by 80 comes out to 0.072375. We're just going to call this 0.07. Okay? So that's the price per ounce. But the trick here in this question was knowing this, right? That you had 4 bottles. Each bottle had 20 ounces. And 4 times 20 is 80. So that's what you actually bought. Number 2. So 2 containers, they're leaking. So we want to see which one is leaking at a faster rate. So we got to compare. And anytime you want to compare something, it's easier if you compare them as a unit rate. So one is leaking, and the other one's leaking. So let's make them both in terms of hours. Okay. So first one, 3/5 of a gallon in 1/3 of an hour. This one's easy. So change the unit rate. We're going to multiply it by 3 over 1. Multiply this 3 over 1. So in 1 hour, this fell over here is 3 times 3 is 9. So 9 over 5, which is the same thing as 1 4/5. So every hour, it's leaking 1 4/5 gallons of water. So that's the first one. The second one says leaking 4/5 of a gallon every 15 minutes. Okay, so this one you have to be careful, because if you divide this by 15, you got 15 divided by 15, but you actually get the unit rate in terms of a minute, which is not what you want, because here is in terms of an hour. You want something out of a minute. This one's a little bit trickier, a little bit different. Now, if you change the 15 minutes to 1/4 of an hour, then you can multiply by 4 over 1, and then the top by 4 over 1, and let's see what we get that. So we do it this way. No, actually, come back and do it the other way too. If we do it this way, we get 1 hour. And over here, 4 times 4 is 16. 5 times 1 is 5, or 3 1/5. So this one is losing a lot of water per hour, right? 3 1/5 of a gallon. So that's easy. But let's say you're stuck with this, tomorrow, and you're looking at this, and this says 4/5 of a gallon every 15 minutes. Well, how many 15 minutes are in every hour? In 1 hour, right? We have 15 minutes, another 15 minutes, you have 15 minutes, you have 4 groups of 15 minutes in 1 hour, right? So 4/5, so in the first 15 minutes, you will lose 4/5 of a gallon. The second, the same thing. The third, the same thing. And the fourth is the same thing. So 4/5 times 4, so we multiply this by 4. 15 minutes times 4 will give me 1 hour, right? 60 minutes. And this would be times 4. Again, it gives you the same answer, or I should say 3 1/5. So it really depends on what you have. So just think carefully. Okay, make sure as to your units. Did everybody get that? Yeah. Okay. So Sam can do 6 push-ups. 6 push-ups here in 12 seconds. And the other guy can do 10 push-ups in 15 seconds. Now, you can find the unit rate and figure out how many push-ups they do in 1 second and then multiply it by 60 if you like. Or you can do this. 1 minute is the same thing as 60 seconds. So let me write 60 seconds on the top bottom. And then push-ups. Well, if this guy can do 6 push-ups in 12 seconds, well, see if there's a relationship between 12 and 60. There is. It's 12 times 5. So therefore, the top is times 5. So 6 times 5 is 30. So this guy can do 30 push-ups in 1 minute. The other guy, well, again, find if there's a relationship again. 15 times 4 is 60, right? And then on the top is times 4. So this guy can do 40 push-ups in 60 seconds. What's the difference between them two? Well, obviously this guy here can do more, and how much more? 10 more push-ups. Push-ups. 4. I wonder how many people watch this. A robot can walk half a mile in 5 minutes. We want to know how long he's going to walk in 24 hours. And good thing he's a robot. So let's figure out how we're going to do this. So let's figure out how many he can walk in 1 hour. Now, how do I change this 5 minutes to 1 hour? So my advice would either be, well, change the 5 minutes and let's rewrite that. Rewrite that in terms of hour. So 5 minutes is the same thing as 5 over 60. Right? And then if I multiply this by the reciprocal, I can multiply this by the reciprocal. And I'm going to get 1 hour over here. And this is going to be 30 over 5, which is 6 miles. Now, it's times 24 and times 24. 6 times 4 is 24, goes to 12, 144 miles in 24 hours. I'll do this again a different way. If anyone is out there listening. Half a mile in 5 minutes. So again, this is almost like the previous problem. Let's figure out how much he does in 1 hour. So in 60 minutes, so in 1 hour, so think how many 5 minutes interval, 5 minutes, what do you call? 5 minutes groups, I got groups of 5 minutes are in what do you call? In 60, right? There's 12 5 minutes interval in 60 minutes. So to figure out how much that robot's going to walk in 1 hour, we can multiply this by 12, right? Because there's 12 groups of 5 in 60. So 5 times 12 is 60, right? Or 60 minutes, which is the same thing as 1 hour. And the top we multiply by 12. And half of 12 is, what is this? Half mile times 12. This is going to be 6 miles. So in 1 hour, he walks 6 miles. And we're going to multiply this by 24. And this by 24, right? So in 24 hours, how far can that robot walk? So again, it's going to be 144 miles. So careful with this question. It's not as easy as it seems. 5, the ratio of something and something. Ratio of chairs to tables. So for every 6 chairs that you see, there should be 10 tables. I wrote 10. Now, if I have 15 chairs in my class, how many tables do I need in my classroom? Well, to keep this relationship the same, right? Let's set up right proportion, right, equals. So if I want to know how many tables I will need to keep that proportion the same, I'm going to write x. Cross multiply, 6 times x is 6x, 10 times 15 is 150, divide both sides by 6, and I get some magic number. 150 divided by 6 equals, so I need 25 tables to maintain that proportion. The distance from New York City to whatever, Baltimore is 300 miles. That's about right. The distance on the map is 20 centimeters. What's the map scale? Well, we can write the map scale in this way. So 20 centimeters right now, all I know is that 20 centimeters on my map is representing 300 miles. Now, this might be a multiple choice question yet tomorrow. So although this is the right answer, we want to simplify it, right? We don't want to write 20 centimeters to 300 miles. Let's see if we can bring it down a little bit. So 20, 300, simplify. So if you can put that in your calculator, press the sim buttons. Right, so let's see, 20 divided by 20 is 1. 300 divided by 20 is 15. So better stated would be that every centimeter on your map is equal to 15 miles in real life. Okay? That was easy. 7. All right, 2 more questions. The average height of an ostrich. You know, an ostrich is that bird. 100, right? So 100 inches. And then there is a model Model ostrich. Hang on a sec. Hang on, I got it. I gotta pause this for a second. Pause. Alright, where was I? So here's the ostrich. It's 100 inches tall. And the baby ostrich, not baby, the model ostrich is 24 inches. So you saw an ostrich and you decided to make a model ostrich. But not of 100 inches, 24 inches. What's the scale factor going from the actual ostrich to the model ostrich? So obviously the actual is the real one, which is this guy. And we're going from big. So the big ostrich, you reduced it inside and you made it into a small one. And then, so we know that the big ostrich is 100. So 100 times a number gave you the small one, right? It was reduced, so your ostrich was reduced here from big to small. But what factor? Divide this by 100. Divide this by 100. X equals, let's see. Let's reduce this. So 12 over 50. If I simplify it one time, I can simplify it again, divide by 2, and then I get 6 over 25. So here is my scale factor. Okay? So 6 over 25. So that's the answer I was looking for. Numero 8. Sam constructs a scale model of a soccer stadium. So you're doing one of your science projects and you need to draw or build one. So there's a soccer stadium that measures 9 inches this way and 11 inches this way, right? So you built it up using whatever materials, and this represents the real soccer stadium in real life. And the question is actually asking you, what's the actual area of the soccer stadium in real life? Well, in real life it's pretty big, right? So let's figure out what this is and what this is. So 1 inch is 25 feet, which means, let's talk about this one, 9 inches. What's 9 inches represent in real life? So that's an x. We have cross multiply, and x times 1 is x, and 25 times 9 is 225, I think, right? I don't know. 9 times 25. Hey, look at that, I was right. So the soccer, 229 feet. So this 9 inches in real life represents 225 feet. Not done yet. I'm going to come back, and I got to measure this other side and see what that is in real life. And hang on a second. Alright, so where was I? Alright, so now we have to find out what 11 inches here means in real life. So again, I'm going to use the same proportion. 1 inch is 25 feet in real life, which means 11 inches. Well, again, cross multiply. 25 times 11 is 275. So this side of the stadium measures 275 feet. We're not done because we actually want the area, right? So the area is going to be, now let me take the 9, take the 11 now. So in real life, the stadium is at 225 times 275 feet dimension-wise. So it's a big, big stadium. So if we multiply 225 times 275, the area of the stadium in real life is 61,875 feet. And don't forget the unit, square. Okay. One more question. Use a scale. So if you use a scale for this map using a ruler and you measured in centimeters, you would have gotten that the distance between A and B as a straight line, where's B? Right here. If you measured that, it would have equaled to, hopefully everyone got the same, 13 centimeters. So on the map it's 13 centimeters, which means in real life it's, I don't know, let's find out. So here's my scale. 1 centimeter equals 75 miles, which means that, again, centimeters and miles. So 13 centimeters on the map is equal to how many miles, and that's going to be my x. Simple enough. X times 1 is x. 13 times 75 is going to give me 975. So in real life, the distance between both those two cities is 975 miles. And again, you will see some representation of these questions. So they're not that hard. Just make sure you do them.